Welcome to this overview of the solar module production process. In the next few minutes, I'll show you how individual materials are turned into a fully tested, high-quality solar module, step by step. Every production starts with the right materials. For the main materials we need glass encapsulant film, solar cells, a backsheet or second glass, a frame, and finally the junction box and sealing materials. These components form the foundation of every solar module. The entire manufacturing process follows a clear sequence, from raw materials to the finished solar module. First, individual solar cells are connected in strings to create the electrical circuit of the module. Then comes the layup, where these strings are positioned on the glass, already covered with encapsulant film. After that, the second layer of film and the backsheet or rear glass are added on top. This complete stack then moves into lamination, where heat and pressure permanently bond all layers together. From here, the module continues through framing, junction box assembly, and final testing before it's ready for shipment. The process starts with the bottom glass, the foundation of every solar module. This glass is carefully cleaned and placed on the production line. A layer of encapsulant film, usually EVA or desert foil, is then laid over the glass to cushion and seal the cells. Next, the cell strings arrive from the stringer. They are positioned with millimeter precision on the foil-covered glass to form the electrical layout of the module. The strings are connected together through bussing, where the main current paths are created. Every connection must be perfectly aligned to guarantee electrical performance and visual quality. Finally, another layer of encapsulant film is placed on top to fully embed the cells and protect them during lamination. Once the module stack is complete, with the glass, encapsulant films, solar cells, and the backsheet or rear glass, it moves into the lamination process. Inside the laminator, vacuum and heat work together to remove any trapped air and permanently bond all layers into one solid structure. The temperature typically rises to around 150 degrees Celsius, while pressure ensures that every layer is sealed tightly. This step gives the module its mechanical strength, weather resistance, and long-term stability. When it comes out of the laminator, the module is fully encapsulated and ready for further processing, trimmed, framed, and tested for quality. After lamination, the module is still a rough panel. The edges are sealed, but excess material remains. The first step is trimming, where any overlapping film or backsheet is precisely cut away to achieve clean, uniform edges. Next, sealing tape or silicone is applied around the perimeter. This creates a tight moisture barrier and ensures long-term protection against environmental stress. Finally, the aluminum frame is mounted. The frame gives the module its final rigidity, defines its dimensions, and makes later handling and installation much easier. At this stage, the module now looks complete, but it still needs electrical connection, testing, and final inspection before it's ready to leave production. Once the module has been framed, it goes through a detailed manual inspection. Trained operators check every surface for scratches, air bubbles, or visual defects. Even small imperfections can affect the long-term performance or appearance of the module. After inspection, the junction box is attached to the back of the module. This box contains the electrical connections that link the module to the solar system. The contacts are connected using conductive adhesive or soldering, and the box is sealed to protect against moisture. Once cured, the junction box forms the electrical heart of the module, ensuring safe current flow and long-term reliability in the field. Before any module leaves the factory, it must pass a full series of electrical and mechanical tests. The first is the flash test, a short burst of artificial sunlight that measures the real electrical performance of the module. This determines its power class and verifies that it meets the rated specifications. Next comes the electroluminescence test, or EL test. Here, a special camera detects even the smallest micro cracks or hidden defects inside the cells that are invisible to the eye. Finally, the HIPOT test ensures electrical insulation and safety. It checks that no current leaks through the module structure, an essential step for reliability and long-term operation. Only modules that pass all of these tests continue to labeling and final packaging. After all tests are completed, each module receives its individual label and serial number. This label contains essential data such as power rating, voltage, current, and manufacturing details. The next step is potting, a protective sealing process for the junction box. A special resin is poured inside to secure the electrical connections and protect them from moisture and temperature changes. Once the potting has hardened, the modules move to final packaging. They are cleaned, visually checked one last time, then stacked and palletized for shipment. At this point, the modules are complete, fully tested, certified, and ready for installation anywhere in the world. That was a short overview of the solar module production process, from the first glass sheet to the finished, fully tested module. If you want to learn more about specific technologies, production steps, or how to start your own module manufacturing line, make sure to continue with the next videos in this PV Know-how course. If you're planning a new factory or need support with equipment and setup, feel free to reach out to us at JVG Technology GmbH. We are here to help you bring your solar project to life.